Welcome. Today we'll find the derivative of the exponential function y equals e to the negative mx. Let's start by writing out our function. Before we begin differentiating, let's recall two important rules. First, the derivative of e to the x is e to the x. Second, we'll need to use the chain rule. Since we have a composite function, the exponent contains negative mx. Let's identify the parts of our function that correspond to the chain rule. The outer function is e to the power of something. That's our f of x. The inner function is negative mx. That's our g of x. Now let's apply the chain rule step by step. First, we take the derivative of the outer function, keeping the inner function in place. The derivative of e to the x is e to the x, so we get e to the negative mx. Next, we multiply by the derivative of the inner function. The derivative of negative mx is simply negative m. Combining these parts according to the chain rule, we multiply them together, e to the negative mx times negative m. Therefore, the derivative of y equals e to the negative mx is negative m times e to the negative mx. Let's visualize what this means graphically. Here's our original function, e to the negative mx for a positive value of m. And here's its derivative, negative m times e to the negative mx. Notice how the derivative is negative, showing the decreasing nature of our original function. To summarize, we found the derivative of e to the negative mx by applying the chain rule. The result is negative m times e to the negative mx. This shows us that the rate of change of an exponential decay function is proportional to the function itself, a key property of exponential functions.